Hi, I'm Ria and this is my friend Sanket, who is a data scientist.
Hi guys, we are back to have a deeper look into the data science terminology. In the last episode, you learned how to infer data from slices through statistics. Now, let's learn how to transform this data or information into knowledge through supervised learning.
Humans learn through experience.
While computers, as we know, do what they are told. But can computers also learn from past experiences?
Yes, they can. Machine learning has given today's computers an entirely new set of abilities. But the main question is, how are these abilities built into a computer? We will tell you one of the most common ways of teaching computers to learn from experiences, a method which is called supervised learning.
Let's have a better understanding of this with an example. Let's say you want to build a party menu planner, a machine that answers whether a food item is tasty or not. This machine can be called a model, and this model can be trained to give correct answers through a process called training. The aim of training this machine is not that the machine gives correct answers to our questions all the time, but it gives correct answers most of the time.
To train this machine, you will need to help it with the information on which food items taste great and which don't. This is called the training data set. The process of transforming information from the training data set into knowledge, which the machine can use later to answer a new set of questions, is called modeling. And this knowledge itself is called a model.
So, to build this model, you need training data. And to collect the training data set, you decide to throw a party to a group of your friends. You would smartly plan a diverse menu and a post-party survey to collect as much information on the various items on the menu as you can, while ensuring everyone is having a great time.
There are many characteristics of the items on the menu based on which you can collect your data. For simplicity of the survey, you decide to collect 5 characteristics, whether salty, cheesy, sweet, a fruit, or a vegetable. You let your friends also write a final remark on the menu item, mentioning whether they found the item yummy or not. Your data will look something like this.
Looks delicious. And as you are a great friend, your idea is to create a machine that can use these characteristics to sufficiently conclude whether you should include or remove a food item from the menu for the next time you throw a party for these friends. These characteristics are called features in machine learning terminology. In some cases, only a few characteristics may be good enough to decide whether a food item is yummy or not. Such features are called significant features of the model.
You also make sure that all your friends fill up the survey correctly, because the more data you collect and the better its quality, the more is the predictive power of the model. If a few of your friends make some errors, then you do have certain tools to eradicate them. For example, your friend Anubhav fills up the survey twice, and then you use deduplication to remove the extra record. Piyush loves playing pranks on you and decides to write essays in the survey. You simply remove any records that contain entries with word length more than 1.
Now let's say another friend of yours, Aparna, was in a hurry and decided to write Y's instead of yeses in the form. You use structural error correction to replace Y's with yeses. There could be many other data preparation needs based on the quality of the data set you collect. In our case, we are fine.
Now that you have collected quality data, you decide to sample 70% of the survey responses to train your machine and use the rest of the 30% to evaluate the machine's responses against your friend's actual responses. These are called train dataset and test dataset respectively. Train dataset will help you create the model. Test dataset will help you evaluate the accuracy of your model.
As a data science learner, you will learn many different models in the upGrad data science course. In our case, we can use a simple rule-based model to come up with a decision chart to train our machine. For a given combination of characteristics, you decide that if more than 70% of the surveys say it's yummy, then any new item with those same characteristics can be said to be yummy, helping you make decisions for the next time you throw a party. Essentially, what you have created is a set of decision rules. Well, you will learn about decision trees later in the upGrad data science course. This is how your decision tree looks. Turns out your friends are not healthy eaters, and you now use this decision tree model to choose new items for your menu.
But before jumping into prediction, we must first check how this model evaluates against data that it has not yet seen. Here is where you need to use the test dataset, the 30% section that you had kept aside. There are various techniques to evaluate the performance of a model, and you will learn them in the upGrad Data Science course. You now want to decide if cheesy nachos is a good option for your next party. You run characteristics of cheesy nachos through the decision tree, and voila! Your model outputs yummy.
You now have a machine that can make decisions on which food items to add or not add. As you keep throwing more parties, collect more training data, your model will become more accurate and you will keep impressing your friends. You may also add more characteristics to collect data on, like served hot or cold, spicy or not, creamy or not, to improve the model.
Now that you have successfully thrown a great party and also understood supervised learning, you are all set to learn about unsupervised learning in the next episode.